All right, welcome back to the Owens Recovery Science Podcast. I'm very excited for you guys to hear today's conversation that we had with Dr. Jamie Burr from the University of Guelph. Johnny and I chat with him about a lot of the work that they have been doing over the years, and their work is really broad-ranging from those that are ill and deal with various types of metabolic disease processes and how do we use exercise interventions to combat those things and how do they influence the safety for the prescription of things like blood flow restricted exercise, all the way out to the real elite athlete and how might we use BFR or ischemic preconditioning to enhance performance for those individuals. So I hope you will give this one a listen. Make sure to really pay attention because at one point in this podcast, Dr. Burr, he actually tells me that I had a very neat idea, and so I'm still kind of riding high from that compliment for what it's worth. Also check the show notes. I've put a bunch of the papers that we discussed in those show notes, as well as a YouTube video that Dr. Burr did where he describes a lot of the work that they have done within that lab. If you're interested in learning more from us at Owens Recovery Science, be sure to shoot over to our website, owensrecoveryscience.com, and check out the certification courses that we have planned all around the world at this point. We've got a lot of stuff going on in the US, but got some courses starting over in the UK, and check it out. Down under, baby. We're going to Australia, so make sure you check that out if you're in Australia and you'd like to learn a little bit more about how we approach this thing called BFR exercise and how we really feel like it might be used to help our patients get better a little bit faster and improve their quality of life and that sort of thing. So look forward to meeting you at these courses. And for now, let's kick it over to Jimmy McKay so we can get going with this podcast.
This is the Owens Recovery Science Podcast, hosted by physical therapist Johnny Owens.
All right, Kyle, I'm skipping the intro today, man. We always just do this dumb welcome to the Owens Recovery Science Podcast, and people probably know they're the two people listening know that it's Owens Recovery Science Podcast. So I want to get right to our guest, and also I don't want you to go into one of your boring ass stories again, and we lose the other.
I'm working.
Nope. We're going right into it. So,
one way or the other.
we're super excited because we got our friend Jamie Burr on, who, if anyone follows the blood flow restriction space or the ischemic preconditioning space, he's like one of the experts out there. We talk about him a lot on this podcast in a good way. And so he's a colleague and a friend. And so Jamie is, man, I'm from West Texas, Jamie, so I'm never sure if I say this right. It's from the University of Guelph, right? Like elf, like shelf.
It is like, it's Guelph, actually.
Oh, Jesus. I can't even do that. English is my second language. My first language is bad West Texas English. So, okay. Guelph up in the Great White North in Ontario, Canada. And so he runs the Human Performance Lab up there. They do all sorts of stuff from looking at performance to, elderly and it kind of runs a gamut. It's not a one-trick pony lab. And so I just pulled out one of my favorite kind of lines that I've seen in the description of the lab. And it's our lab specifically focuses on novel perturbations to normal physiology, including factors such as blood flow manipulation, applications of training and monitoring techniques and supplements. So basically taking things and manipulating it, seeing if you get this kind of hormetic response or something else. So thanks for being on, man. We had a little bit of an issue because Stephen Patterson stole our Zoom this morning because he's too cheap to buy a pro account. And so he's using it over there. And
we say nice things about Jamie, but not about Stephen.
That's a good pattern. Let's keep with that. Well, thanks for having me on, guys. I'm glad we got it to work out, and it's a pleasure to be here.
Yeah, thanks for coming on, man. And so you want to tell us just a little bit about your background and your lab, and we focus on a lot of IPC and BFR obviously on this, and kind of how you got into that space.
Sure. Yeah. I think my lab brings a bit of a unique perspective to the area. While we do a lot of work in blood flow manipulation, meaning ischemic preconditioning and blood flow restriction training, we come from a perspective of integrative physiology, I would say. So if you were to look at the publications coming out of our lab, they're certainly not all focused on that area. And I think that allows us to sometimes take a step back and look at things from a different perspective. I'm actually trained as a cardiovascular physiologist, which is sort of how I landed here. I'd say a lot of other people probably come at it from more of a muscular point of view. So,
Right.
Yeah, I mean, we are up here in Canada, and I think that's probably worth mentioning as well, just because that probably affects our approach as well. So in the Human Performance and Health Research Lab, we are constrained by probably different things than American labs, I would say, or maybe our European counterparts. We're very interested in sports performance, and that was part of my job when I was hired to come to Guelph. That's how it's pronounced. But it's unique in that in Canada, we don't have a lot of agencies that will fund sport performance specifically. So you will often see that we have a health twist to what we do, or we're looking at it really from a mechanistic science point of view.
Yeah. So the Curling Society doesn't fund a lot of research for sports.
We are sponsored by Curling and Maple Syrup Canada.
Johnny wants to know, Jamie, let's be completely transparent here. The main curiosity that he has is, are there performance enhancing benefits to coupling poutine intake with BFR? That's really what he wants to know. Like,
both are going to stop blood flow pretty quickly. It's just different mechanisms.
I was up in Montreal working with Cirque, and man, I couldn't stop eating poutine. I even bought a poutine T-shirt that I wear all the time now. So.
We went from Johnny saying protein all the time to poutine all the time. I don't know what happened.
Poutine stuff, and I was like, "What are you talking about?"
What do you mean 20 grams of poutine, Johnny?
I taught the course, and I was like, "Man, I had poutine last night. It was amazing. I didn't know where to go, and I was in a hurry." And they were like, "Where'd you go?" And I said, "McDonald's." They were like, "Jesus Christ, you ate it at McDonald's."
That's not even good poutine.
I know. Well, so I think what people are going to really be interested in from your perspective too is, you really understand the performance space quite a bit more, as well as the IPC stuff. And so you guys had a paper that just came out in Journal of Applied Physiology. I think it came out like a week or two ago, on blood flow restriction training and the high performance athlete from science to application. Danny Christensen, who's done a bunch of cool stuff as well, with performance and how BFR might manipulate that. So one of the things that was really cool in there, and just maybe you want to give an overview, what do you think BFR, not IPC, but BFR kind of fits from the strength kind of athlete to the endurance athlete? And I know there's a blur of what those lines are.
Yeah, I mean, I think it's an interesting space. And one of the things that we highlight in that paper is there is more evidence coming out actually looking at elite athletes, but a lot of what we have in the literature now is done with sort of your recreationally active participants. And for anybody who works with elite athletes, you know that they're a tough group to study for a few reasons. One, because they're elite athletes, so you got to be very careful what you do. We rarely, if ever, take muscle biopsies from the Olympians in town. It's often just not worth it. So that's one thing we've got to be aware of. And the other is that oftentimes when we see changes, whether we're talking about blood flow restriction or anything else in the training sphere, a lot of changes that might happen in less trained people are unlikely to happen in elite athletes because they may have manifested that change already just as a result of their years of training. So it's an interesting area to get into, to think about, can we actually cause these changes in these athletes on top of what they're already doing? I guess the other side of that too is it too much of a stress to add on to these athletes as well? Because that's usually the first thing you're going to cover with coaches when you get into this. It's like, okay, well, what's it going to do to them, and how much is it going to throw off those things we already deem important? So that was kind of the perspective we took going into this, and understanding where's the field going now. We tried to explore a little bit into the mechanisms of what might be causing these changes at a muscular level, at a cardiovascular level, and to say, is there a point in doing this? And I would say overall, we conclude that there is pretty good evidence that suggests there is a real effect of these things. A number of things that we can do will affect an elite athlete, and perhaps is the icing on the cake. It's not that we're going to replace all of their training with blood flow restriction, but there may be added benefit to that. And we try to highlight some knowledge gaps as well. What do we need to understand a little bit more before we can conclusively say this is the thing we should be doing with these athletes?
Yeah, I would encourage anyone. This is I would say, the best overall review of BFR and its application from a performance perspective. I mean, you guys, it's well done. And if anyone's interested in this, I think this is going to be the go-to paper as of now. And I think what our questions we get all the time is this something that should be done as an additive? Is this something that should be done to replace, like maybe periodizing it in season, kind of taper them down and, got these nagging injury type things. There's one paper, the Bjornsson one, Olympic lifters, just adding a little bit of BFR to it just really made some interesting changes from that. So what do you think from that?
Yeah, I mean, that Bjornsson paper, I think, is a great example of, these were, for those who are not familiar with it, they were very well-trained powerlifters. And if I recall correctly, they added only 2 separate 1-week blocks on top of their regular training. And so that's pretty compelling evidence that this short little bout, like this high-intensity dose, if you will, only in the group that actually added the BFR, they saw these fairly substantial changes. So I think it does depend on the sport and the demands of the sport. So powerlifting is obviously very different from marathon running, for example. And how you're going to use that is probably dependent on what kind of changes you want to get at. So whether we're talking team sports where it's repeated sprinting, or you're talking something that's pure power, or you're talking about something that's endurance based, I think the way that we approach the restriction pressures and the doses, if you will, cycling through, I think we have a lot more to understand, to be honest.
Yeah.
But I think that it's very context dependent. So it probably is something that's periodized, not used all the time.
Right.
Like any other stress, it's expected our body will adapt to that. So.
Yeah. Yeah. And it's pretty cool. 10 sessions of BFR just added onto that strengthening block. everything, fiber size, myonuclei content, strength across the board. Without it, they didn't see those changes. So that's what the teams say, okay, can we just kind of throw this in throughout the season? And the other question we get to, especially from this kind of like a powerlifter perspective, or they're doing a lot of heavy strength work, is when would you throw that in? Is this like throw it in pre-work? I do my BFR, then I go do this, I do my session, and then I do BFR as kind of this like finisher, or I have the guys come back, 4 or 5 hours later and we throw a BFR session on.
Yeah, exactly. So, and I think that's where we need to think very carefully about individualizing this to the athlete, because periodization will be done very differently. So let's say that we're using this to improve aerobic capacity, for example. There's increasing evidence that we can actually make even quite fit athletes more fit. Mm-hmm. So when we think about how do we want to use that, we probably want to be using that to get them ready for the next bout of training, because ultimately you want to specialize as close as you can to what they're going to be doing in their competition as you get closer to that competition. So in that case, that might be something we're using a few weeks out, maybe not right before. If you go to, there's some really, really good data. There's maybe about 6 studies now that show VO2 max, for example, it improves. And one of the first ones that caught our attention was by Ferguson's group in the UK. And they used really well-trained cyclists. And they showed an increase of about 5%, I believe it was, in VO2 max. And these guys were starting in the mid-60s. And quite honestly, when it was first brought to my attention, I called shenanigans, because I was like, no, right? Like, what did you do to these guys? Where I think it was a 4-week study, so 8 sessions. And they saw this big jump up. And I went, that doesn't happen in people that well-trained. But to their credit, they did it again. And they did very strong science. They did a good job of explaining at the muscular level what kind of changes were happening or not happening. But they can cause these changes in these athletes. And it's now been repeated with lower doses. So in that study, they started off using repeated wind gates and like we like to call it marinating in between. So they'd get off the bike after going like stink, and they'd trap blood in their legs and wait for 2 minutes and then repeat that. And other groups have now shown it with light load walking. We've seen it in rowers, relatively light rowing, and rowers are aerobic animals to begin with. And they saw a 10% increase. So those kind of things, again, that's where I go, okay, well, what kind of athlete are we talking about? What dictates really good performance? And how do we best use that? So in an aerobic athlete, I may be using that to specifically increase their fitness. Whereas in a team sport athlete, fitness is obviously still important, but it might not be the end goal. In their case, it might be to recover from a shift or, a high intensity bout and then get ready for the next one. So where I would time that, how I would specifically put that in, is certainly going to be context dependent.
Yeah, these aerobic studies, when they seem to just keep coming out always positive. It's just, I'm done with clinical BFR trials because they suck ass to do. I'm just going to do these aerobic trials because they seem positive. And so looking at that from, obviously your cardiovascular experience, what do you think mechanisms is? We talk a lot about, reduction of stroke volume, maybe changes in mitochondrial kind of, not density, but improved capacity. What do you think?
Yeah, I think there's a few things to consider there. One of the interesting things that we see right now is that VO2 max does go up. So gold standard measure of aerobic fitness. There's not a lot of evidence yet that shows performance is increased as well. There could be some explanations for that. Perhaps what we're exposing these athletes to is actually a bit of an overtraining stimulus. I don't want to give away too much about what we have going on right now, but
you don't have to.
Well, in COVID, we've
you can do it off air, Jamie. It's fine.
Yeah. Okay. And then I'll present it at my next conference.
Fine. Yeah. Pay no attention to the slides coming out of ORS for the next year.
Just send us some graphs, right? I will tell you, we're very interested in this, and we've tried a variation on this protocol of like sprinting, short sprints, and then occluding. And one of the things that became very apparent to us, we thought we had a fairly light protocol, and we did it for only 2 weeks, and we were taking all sorts of measures on ourselves, and we were really beat up afterwards. And I point that out because another focus of my lab is overtraining. What happens to the cardiovascular system and to performance when we intentionally beat the crap out of people for a few weeks? And this felt a lot like that. So when I look at some of those studies, I go, well, if you tested them right after you'd been training them this way, maybe they did see these big improvements, but it's kind of masked by the fact that they're depressed in their ability to actually put out that kind of power performance. So we see VO2 go up, we don't see performance. Maybe with a little bit more of a taper and a rest, that could go up, but that's a really important question to us to sort of get to the bottom of.
It seems like it would kind of point back to maybe that heart rate variability study y'all did, and then maybe Nielsen's work where they showed that, increase in strength over the next, what was it, 12 days or
10 days
or something, 10 days. Yeah, there was, maybe this recovery that was happening that allowed people to perform better.
Yeah, absolutely. So the study that we did that you highlight there, where we looked at heart rate variability, when we first started playing with using ischemic preconditioning, and adding an exercise component. So we're kind of blurring the lines between IPC and BFR. One of the things we all noticed was we felt kind of fuzzy afterwards. And we went like, what is that?
I was wondering how y'all could even pull that study off, man. I mean, it sounds terrible.
Yeah, we do a few things that don't make us very popular in the department when we go recruiting. But for those who are not familiar, essentially what we did is we tracked heart rate variability to understand a little bit about sympathetic and parasympathetic tone. And the major finding of that study was that it is a big training load. Even though it doesn't take very long, it's kind of like a HIIT protocol. In this case, we were just cycling with blood flow occlusion on at a pretty light, I think it was 50 or 100 watts. But we saw that even the next day, people were still kind of messed up. So our conclusion from that is like, you've got to be careful. This is a big training stress, even if it doesn't seem like it.
Right.
There's also some stuff that suggests, just by changing blood flow patterns, we may be changing endothelial function, for example. So perfusion of the muscles may change. So even though we might be causing an effect away from the muscle, maybe centrally we're causing VO2 to go up, but we might be affecting the way that the muscles are able to take up and use oxygen, for example, or supply the tissue.
What do you think also, you've done some work looking at the free radicals and potential antioxidant type work. I know Danny Christensen, who's on this paper with you, that's something that with their glucose study, that maybe it was this increase in antioxidant or GLUT4 or whatever. What do you think in general BFR does with that? Takes it down? You got more of a kind of buffering, and that might be beneficial.
Yeah, I think that's a really interesting area. I mean, I know I don't have to tell you guys, but one of the frustrations with this area is we as scientists, we don't really understand how BFR works yet. There's a lot of good theories about what might be happening. And one of those is that it's driven by a reactive oxygen species. So in the study you mentioned, we paired up with Graham Holloway's lab, another researcher here at Guelph. And he does much more tissue level molecular work than I do. But we what we did in that case is we had people come into the lab and we did a muscle biopsy to just get a baseline on them. Then we had them actually do a hard BFR set, and we took more biopsies after. And so 2 hours after, we were able to look at the tissue and understand what's going on at the mitochondrial respiration level and what's going on with ROS production. Long story short, we actually showed that from the mitochondria point of view, ROS, it actually goes down. And maybe that now when we look back, we go, well, that's probably not surprising that if you need oxygen for these reactive oxygen species and you limit oxygen, it went down. And in that study, we also compared experimentally changing oxygen levels in a respirometer to see what happens when we take it away from the human body, using human tissue still. And sure enough, that seems to be the case. So mitochondrial respiration, mitochondrial ROS is maybe not the be all end all, but it does give us some insight about, is that likely a driving factor? And perhaps it's not.
Right. And I think we're also interested in our clinical side, these oxidative stressed out individuals, you're obese, you're diabetics and things like that. Is this an intervention where maybe we are limiting their free radical load and they've all got this just terrible endothelial kind of function. So this is, and we had a Parkinson's study trial that we were working with at Baylor down here, and they showed that as well. They really improved endothelial function in these oxidatively stressed out individuals. So I think that's fascinating work we're gonna have to see more and more of.
Yeah, and I think it's really neat too when we think about how do we apply this moving forward. I mean, there's one thing to talk about sort of our normal or pseudo normal participants, because anyone that wants to do this is pseudo normal at best. But then when you take that to whether it's clinical populations or athletes, I mean, they're really at different ends of the spectrum. And so to give you an example of how we often think about this with things like inflammation, it's common that people say, like, if you have obesity and diabetes, you're probably walking around with chronic low grade inflammation. And we know that that's generally bad. Mm-hmm. And people, it's tempting to take that to athletes and say, like, well, inflammation, bad, right? Mm-hmm. And so there's some pretty compelling work now that shows, yeah, sure, an athlete gets inflamed after a good hard workout, but that was kind of the point, because if we knock down that inflammation, then they actually don't adapt. Right. And so, our thinking on like ice baths and, high dose, even vitamin E and vitamin C will cause the same effect. So I think we need to keep that in mind when we think about blood flow restriction and how would we use it for health improvements or performance in sort of getting through everyday life, versus how do we use that with an elite athlete, because their buffering capacities and all that are going to be very, very different.
Totally different. Yeah. Okay. So we've got, if we are looking at from a strength perspective, it looks like throwing additional BFR might be something that an athlete could benefit from on top of their training load. I think you guys mentioned in your paper as well, Per Argard's recent systematic review and meta-analysis that, hey, BFR did just as well as lifting heavy when they kind of took the better papers, didn't have the double dipping effect and all of that. So maybe it could be something you swap out if need be. You're in a hockey team that's traveling a lot and they just want to do something a little bit lower load on their guys when they're in a playoff or something. And then we've got the aerobic potential. And, I guess the different flavors, we kind of just, because it's easy clinically, we just kind of, let's just do steady state. We're going to kind of follow the ABE protocol or whatever. But now, we've got all these different protocols. It's either do it during intervals, do it during rest periods. So there's different ways to skin the cat. What do you think, like looking at the aerobic one overall, if you're to say, like, I'm going to start working with, some endurance athletes, would you look at an interval, a rest protocol, a steady state?
Yeah, I think you hit the nail on the head there. I think that's where we're going to see a lot of this work go, is that, traditionally we have said, okay, well, we'll just choke off blood flow and then we're going to do something. And we're either going to walk on a treadmill or we're going to bike or we're going to lift weights. I think there is pretty good evidence now that that's not always the best way to go about it. And this cycling is maybe, depending on your goals, a better way to approach it. So for example, if I want somebody to really get a good quality session in, let's say I'm doing the Wingate style, so 30 seconds all out. If you've ever tried BFR, you know that you're not getting a good 30 seconds if you've got the cuffs on at the time. But maybe we can get that high quality stimulus and then sort of amplify that stimulus by using it in the rest period. So I think that's where we have to get it sorted. I think in terms of understanding both the build and the decay, if you will, of these adaptations, there's a lot of work to be done. Like, how much is enough and how much is too much on the front end, so we don't overtrain athletes, for example, if we're working with elites, and how long does that last? is another really big thing. So when you say like, well, when would you use this? We have some ideas about what probably makes sense. And we can look to things like altitude training or other heat training is commonly done in endurance athletes. And maybe that'll tell us a little bit about like how many weeks would we expect this would last for. Also the life of a blood cell, for example. But we really need to understand that so that we can put it in the best place at the right time.
Right. Well, we'll be looking forward from your lab to direct us, hopefully with some of that work you're doing right now. And then the other point you guys brought up in that paper, and something that you're an expert at, is IPC, or IPC, whatever we want to call it, ischemic preconditioning. And so I think people who listen to this podcast know about it. We've talked about it enough. And I'll just put out, you've got a good YouTube that you did, almost like a Grand Rounds, I think, or something at Guelph, where you went into a lot of y'all's work and also some of the IPC stuff. So how would you describe IPC from what it does? I'll just say IPC is an application of a tourniquet, inflation, deflation, usually 3 to 5 rounds, equal on and off times. It kind of came from the medical side of the house, looking at it with can you spare organ tissue? So how would you describe it from what you think is going on?
Sure. Yeah. I think that's a pretty good explanation, and absolutely credit to the medical field, because sports scientists like ourselves, we totally stole the idea. Yeah. And it really started from an understanding that in the heart, actually, damage could be reduced in myocardial infarction if they actually went in and cut off one of the coronary arteries. They'd use forceps and just cut it off. And they realized the tissue below that didn't have the same kind of damage if they cycled through cutting it off and letting it go a few times, which is neat, but not very applicable to humans. Yeah. So the next step was they realized that if they cut off a coronary artery that was not specifically above the region that was about to be affected, and they could study that by causing MIs, by just basically choking off the artery. That's what they would do in a mouse model. That worked too. And so that led then to understanding that maybe we can do this completely remotely. So in the field, we talk about ischemic preconditioning. More accurately, it's always remote ischemic preconditioning, because we're not actually affecting, we're often not affecting the area that we think is going to be affected. So in exercise, we really took this to say, okay, it seems that if you give a good enough dose of this ischemic preconditioning where you cut off flow, you let it go a few times, it's typically about 5 minutes of occlusion and then 5 minutes of reperfusion. You cycle that through maybe 4 or 5 times, things seem to change afterwards. And if you give a good enough dose, almost every organ will be affected. And of course, skeletal muscle is an organ as well. So this was applied then to say, okay, well, if we do this before exercise, can we actually improve somebody's capacity to perform? Performance studies are, they're interesting. I mean, they're fun. We enjoy them in my lab. That's a big focus for us, but they're also very challenging to do, because whatever intervention you might be doing likely has an effect that is a few percent of overall performance, but there are many other things, motivation, just how you're feeling on the day, all those kind of things can change it as well. So it is a challenging area. And one of the other challenges when we first got into this was understanding, is it all in somebody's head? Because, you do a fancy dance around them and tell them you're going to make them better. Placebo effect is real. And one of the challenging things is when you squeeze somebody at 220 millimeters of mercury, they know that you're squeezing them.
They know something's happening, right?
Yeah. And when you just say, hey, I'm going to put this cuff on and not fill it up, it's pretty clear that you didn't. So that's been something that I think has sort of plagued that area of research, is in understanding, is this a real effect? And that's been a real focus for us in trying to pull that apart and say, is this a real effect? And are we actually making them faster? And if so, by how much?
And you guys did a great study to kind of tackle that, because I know we've seen the editorials, the problems with the performance side, but your nocebo study, where you did the sham ultrasounds and
yeah, I thought you were going right into that, Jamie. You made Johnny set you up there. Like, you're trying to be humble, and I'm like, no. Like, that was a great study. It really was, And it also, I think, as a physio, we all kind of saw ultrasound, and people associated these positive things with ultrasound, and we all just kind of went, "Oh God, here we go. We're gonna go down this road again." But
well, I appreciate you guys saying that. In fairness, we can't really take full credit for that study. So credit where it's due to Sabino Carvalho and their group. They came up with the sham in the first place, where they were going to use the ultrasound. So we read their study, which was done on treadmills, and we went, like, what a great design. But for us, when you're using a treadmill and it's motor driven, that might affect what's going on in performance. And really what I mean by that is compared to like a bike where we just blind people and we don't let them see what's going on. It's just work as hard as you can. And we get a real-time output, right? We get watts. Whereas when you have a motor driven treadmill, we were worried that it might just be that you just kept up because you didn't want to go flying off the back. So if you guys run on treadmills ever, I mean, I know maybe I'm just lazy, but it's like I set the speed, it's kind of set and forget, right? I'll just keep up and not fall off. If I'm feeling great, I'm unlikely to bump it up. Or if I'm feeling, a little bit slower, I'll probably just suck it up. So we went, okay, how do we maybe change that a little bit? So we kind of tweaked that study. But for those who are not familiar with what we did there, the idea with this was to get a sham that people might not be able to figure out what it was, and they might have preconceived notions about what they thought was going to happen. And we let them kind of run with that. So in the one group, we did ischemic preconditioning where they laid on the bed and we, just as I described, we filled up the cuffs and let them go a few times. And then in the other group, we had an ultrasound, like a treatment ultrasound. And essentially what we did is we turned it on and went beep, 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 beep. And then we turned it right back off because they couldn't see it. And then we just rubbed ultrasound gel all over their leg for the exact same amount of time. What I think was neat about this study and really stuck with us is we also asked people, what did you think was going to happen? So when we compared the two arms of the study, it turns out, as we kind of expected, most people thought ultrasound should do something because there is this prevalent belief that, it increases blood flow and that's going to be good. And I've seen right. So they all told us, oh yeah, I'm going to go faster after you did that ultrasound thing to me. And most people in our study did not understand what ischemic preconditioning was, nor did we really inform them. And they actually believed it should make them worse. And I can see why people would believe that because, we inflicted a little bit of discomfort on them before and they could figure out that we were cutting off blood flow and they went, that can't make me better. Cut to the chase, what eventually happened was it was actually the opposite. So they believed they should go faster with ultrasound and slower with ischemic preconditioning, but they actually went faster with ischemic preconditioning. So that can't be a placebo effect if you thought the opposite thing should happen. So that was pretty compelling evidence.
Brilliant. And it's, that's called a nocebo design. We don't have enough of those. So I definitely love it. The other thing, you guys are, y'all use Delphi systems up there. And so you're personalizing this, in these IPC studies more. And I think that was always a fatal flaw. It was a lot of the IPC stuff. It was like, okay, we're going to clamp off 100% of the arterial flow in these animal models. And it showed despair. And then people would follow it up in human models and use a blood pressure cuff and just say, we're going to put 200 millimeters of mercury or 220 is what everyone used. And we know from LOPs that like my legs are yoked. So it's like 500 millimeters of mercury to make mine go off. But Kyle's he's got prepubescent thighs, so he's like 150. We actually call them young thighs. So he doesn't feel bad. So if you're just picking a number, one group, you pointed this out earlier, it's dosing. And I hate that when we look at some of these trials and they don't treat the amount of hypoxia as a potential dose. You wouldn't take, 10,000 grams of ibuprofen and one group does 50,000 and think it's equal. So what are your thoughts on that?
Yeah, absolutely agree. And I think from a BFR perspective, it's really come around to our thinking that like we can't just be using the same pressure, knowing that different people will be affected in different ways. And when you're exercising under load, I think that absolutely is a thing to think about. Our group, thinking about dosing for IPC, we believe we probably do want to cut off most of the flow because that's probably the stimulus. But we also took that and said, okay, well, can we improve upon that stimulus? And that's kind of where we got to this idea of blending, if you will, BFR and IPC. And that's why I often say we work in blood flow manipulation because they're just different ways to accomplish similar goals. So one of the things that really got us going down this path was we tried it with a light stimulus to begin with. So we said, okay, what happens if we do nothing? There's our control. What happens if we do ischemic preconditioning the way it's typically done? So we're going to do this cycling and you're just sitting in a chair essentially while this is passively being done to you, I guess. And then we said, okay, well, what happens if we add a light exercise stimulus? So our two extra groups that we added on, the first one was we cut off blood flow and we just electrically stimulated the muscles below that occlusion. And then the other one, we actually had them walk on a treadmill. And what happened in that study was as we normally see, there were responders and non-responders to this stimulus. And that's as I said, in performance studies, that's a real tough thing to understand. Did they really not respond, or was it just a bad day, or were they just outside of the variance of human performance and how much we would expect, for example, Johnny to be different from Kyle, to be different from me? Like, is it mathematical essentially? And then we had them do each of these studies, and we showed that those who didn't respond to a traditional IPC, when we sort of upped the ante a little bit and added that extra stimulus, there was less non-responders. And we see that in the non-response literature outside of BFR as well. So it might just be that a greater dose is required for some people to sort of flip the switch, and maybe there's a threshold there. So.
Yeah, and Steven's mentioned that. He and I spoke together in DC at a conference, and it's kind of like, okay, if you're going to hedge your bets, maybe do IPC and try and throw stim on, or throw some sort of volitional contraction, and maybe you're catching responders and non-responders all in one group, and one group doesn't miss it.
Yeah, and so to your point that you started with, I mean, it could be hypoxia. Maybe we have to drive tissue oxygenation down, and obviously when we start contracting the muscles, there's more of a draw there to pull out the oxygen that exists. It could also be that maybe it's the other side. Maybe we need a certain level of metabolite buildup, even at rest. If you're marinating, there will be some, because the venous effluent isn't leaving. So
yeah, you're trapping it.
Yeah. Exactly. So we don't know which side we're emphasizing. We're again trying to pull those bits apart to figure out how we optimize that. But
and when you're looking at that was Josh's eStim study as well, the non-weight bearing. You're doing your stim at 100% LOP or full,
yes,
much full occlusion. Yeah. Which is a trend we've been doing more and more clinically. Is okay, if this is a lower stimulus, then we're going to start. It's okay. We're going to take these occlusion pressures maybe up all the way on some individuals. If they, we have to taper up with clinical patients, but I don't think it's bad to go that direction. Right.
Yeah.
I would say clinically, I've gotten some pretty legit in like early post-op people pain reduction responses, which that's a huge win. One specific ACL guy came in and barely putting weight on his limb, couldn't hardly move it. And all we got was 2 inflations on him with stim, and he had a substantial pain reduction that lasted, didn't regress at all. It stayed, and so that's just a huge win on our end from someone coming in. Not only do they think you have a clue about what you're doing on this limb that's just killing them, but then you also see that their function's going to increase, and they're just going to start progressing a bit better. So we've definitely been tinkering with that. So.
One of my favorite responder non-responder papers is that elite swimming study with IPC, where they shammed them and it was like no change at all. And then when they did the intervention, the IPC, it looked like a freaking shotgun on their times. It was all over the place. Some you read the papers, like they were almost like would have medaled in the Olympics after you did this, and a few others, they got worse. So what are your thoughts on that study?
Yeah, I mean, that kind of comes back to the whole idea of like, how do we use this? And with the elite athlete, how do we use it? So that paper was done. It was a Canadian study.
Yeah, Toronto.
It was done in Toronto, where we had some pretty quick swimmers as far as our Canadian swimmers go. We're all living and training there. So for those who are not familiar, that's what they did is they shammed them, or they had them do this ischemic preconditioning. And then they said, okay, go swim your event. And if I recall, it was 100 or 200 meters.
200 meters, I think. Yeah.
And I mean, at that level, when you ask an athlete to do that thing that they do, they're pretty good at doing it, right? So the variation is very small. It's like, go swim as fast as you can and go do it again. There's not a lot of room for improvement. So in the sham, they came in with very little variation. And then they said, okay, now we're going to do this thing. And the improvements were impressive. When I talk about that study, when I give a presentation, I often put up Michael Phelps, and I say, hey, here's where other people would be in the pool over different years when Phelps finished. And you can see, I mean, swimming is won by very, very small margins. So the margin of change that you see from doing this IPC before is a massive effect. Like when we're not even talking like podium or not podium, it's like you didn't even get into the final. You're not even in the conversation. You may not have made the Olympics. So
right.
We're talking the average change would be in 100 meters. It would be a full body length, which is huge, right? Like you're literally not even in the picture when they show the touch at the end. And for those who were the biggest responders, it was 3 times that. Yeah. So pretty cool stuff when you consider that. I mean, if we can cause a change in an athlete of 1% to 2% with anything that we do, including sort of our regular training, we're celebrating. That's huge. And some of these changes that we're seeing in these athletes are at the level that could be considered equivalents of doping, right? Like things that are banned. So that's pretty compelling and exciting.
Yeah, and we've been trying it with some of the teams, and it's been, user beware. Let's try this in practice. Let's see, pitcher, let's do this, and then see, did it change velocity or anything like that, and just seeing it. Because it would be almost a crime to hold an athlete back that responded like that. They're gonna be like, yeah, let's see if this works for me. If I was a pro guy, I would be like, I'm going to try this out and just see what it does. What I think was a really cool too on that study was they're like, well, let's also throw in, is this a humoral response? And then drew the blood and then showed that the preconditioned blood actually spared I think it was the pig hearts from damage. So what are your thoughts of, like, because we get that a lot in baseball, the pitchers sometimes don't like things on their arms. So could they put this on their leg? It's a humoral type thing and avoid having to go with the actual arm.
Yeah, so that was a really cool part of that study, and something we've been interested in for quite a while, where they use what's called the Langendorf model. So essentially you take the heart out of an animal and you string it up on a stick and you keep it alive for a certain amount of time. And it's a good way to model.
We just got so many unfollows.
Yeah, sorry, that's not how we do work at Guelph. But it is a well accepted model for damage of the heart. And so basically, how long can you keep it alive? And I'll be honest, we tried this because we were quite curious about this as well, and it was really hard for us to do because our model is a little bit different. We're not just concerned about preventing damage. I wanted to do it more like a Valvoline, those where they put the car on the dynamometer and they just rev it till the engine explodes. That's the model I wanted to have, and we couldn't quite recreate that. So we've actually returned to the drawing board, and now we're trying it with in a mouse model using skeletal muscle. So we'll be taking out their soleus, and we're actually going to treat human blood different ways. So like I described before, we'll do control where we just take human blood and we spin it down, and then we bathe the muscle in that, and then we're going to shock the muscle and see what kind of performance we can get out of it. And then we're going to treat the blood successively. So then we'll do a normal IPC, or we'll do an IPC with exercise, and we'll bathe all these different muscles and see, like, did it change performance? And what we think is really novel and hopefully insightful about that is we've removed the nervous system completely because it's no longer attached. Right. Now, there are challenges when you go across species like that, but that will give us a good insight of, like, is there something changing in the blood? And we have reason to believe that there probably is, both from this study and some of our own almost happy mistakes, if you'll accept that, is, we tried things and we went, oh geez, like, it seemed like we saw this effect in a different limb that we weren't trying to play with. Why did that happen? Maybe it's because we've changed circulating factors in the body.
So at this point in time, would you be comfortable just say, I'm going to just do it on a unilateral thigh to get this sort of whole effect, or I need it bilateral, or if you're going to be arm dominant, let's go arm? What do you think?
Yeah, I mean, if we look at the IPC literature, people have tried this before where they said, like, is it the amount of muscle mass you're doing or the location? So, like, if you want to be a better cyclist, does it matter if you do it on the arms? You have to do it on the legs. If you do one or you do all four, the short answer is it doesn't seem to matter. We can't quite see that effect. But I don't think it's one thing happening in isolation either. So it is very possible that there's a neural effect and there's a humoral effect, something circulating. Kyle had mentioned earlier too that, pain seems to be affected as well. This is another area we haven't actually published this paper, but we're going to get it in really soon. It's written, where we did this with IPC as well, where we said to people, like, are we just changing how you feel about exercise? Like, we did something that's uncomfortable and it lasts about a half hour. Did we just change, like, the suck level for you, if you will? Like, did you just kind of settle into, I'm okay with it. This hard exercise isn't so bad anymore. I just went through real discomfort. Give it to me. And we also followed it up with tests that were not exercise. So we said, if you were somebody that responds to ischemic preconditioning, do you just change the way you respond to pain? So we did a cold presser test where you stick their hand in a bucket of ice. I mean, it's not the worst pain in the world, but it's a well-accepted test that your body kind of freaks out. Blood pressure goes up, for example. And so then we said, okay, well, does that change the way you felt about that and the way your body responded to that? So we would agree that there seems to be something there. So
Cool.
So not a vat of mercury like Alum and Smirk did like way back in 1937. You didn't get that past the IRB, Jamie. You had to go with the cold water, man.
Unfair, but yeah, they don't let us do those things anymore.
Weird.
Canadian
I don't know, man.
Canadian IRBs, they care about their subjects.
Come on.
So from a performance side, this is good and it's easy to do. You can either just apply it and pre-event, or apply it and maybe have some sort of added dose to it, like we're going to add stim to it or a little bit of exercise with it. Lastly, before we move on, do you feel like there's a timing? We know there's this window and this second window to it. Would you do this 30 minutes before your event, 5 minutes before your event, hours before it?
Yeah. Another great question, a really applied question, and something that we've attempted to dig into as well. I think this happens in most fields of research and we see this in BFR. I'm sure you can relate to this, like the 30-15-15 protocol. Mm-hmm. A lot of people use it because it was one of the first ones done and there was good success with that. So why change what works? Right. And if we look at IPC, we have the same sort of thing where it's like we treat people, we wait a certain amount of time, it tends to be about like 15 minutes, let's call it, and then we do the exercise. So our group looked at that and said, is that the right amount of time? If we look at the cardiac literature where all this started, it appears there's two distinct windows of protection from a heart attack. So you get sort of the immediate effect, and then you get this later window that kind of like it goes away and then it comes back like a day later. Right. So that was intriguing to us because you might look a little bit weird if you show up at the starting block and you've got blood flow cuffs on, right?
Yeah,
everyone's
laying down.
Yeah, what's up, bro? Yeah. So we went, well, can we do this the night before in the hotel room, for example? And does that second window appear at the right time? Or maybe even better than that, can we stack these things? So if there's two windows, what if we get them to line up? So it's like the first window helps you so much, and you can put that on top of when the second window is going to happen, you get twice the effect. So we tried that, where we treated people and then we tested, or we treated and then we waited and then we treated again and then we tested, or we treated and waited and treated. You get the idea. Yeah. And we kept going. Long story short, it didn't seem to matter. We did not see any addition of this effect. It was sort of you responded or you didn't respond. Right.
Which makes it easier. It takes the complication out of it. Because I know some Steven stuff too, is should we do chronic, IPCs to somehow try and help performance, but that is a little bit more of a burden if you have to do 2 weeks worth of IPC just to train up for this event. So just get it on and go.
Yeah, exactly.
Sounds like, okay, yeah. Cool. And then the other thing from an IPC perspective, which we probably use a lot more kind of right now, is looking at it from a recovery. Can you put it on post-bad event and see, and you guys touched on this in your paper as well. What are your thoughts on that of blocking muscle damage potentially or increasing performance?
Yeah. This is, I think a lot of people have had interest in this because theoretically it makes a lot of sense that this should probably work. In-house, we did play with this. We never ended up publishing these results. That was one of the first studies we actually ever did, where we took people and had them run downhill, which is something we use for other work as well to cause muscle damage. And if you've never had the pleasure of running downhill, it's a neat experience. It feels like you're not working that hard, except for your legs. You feel like Bambi by the time you're done. You can always tell people who are in our experiments because they're avoiding stairs for the next while. We actually found that we couldn't change that much in terms of what happened afterwards. Again, maybe we didn't have our protocol right at the time and maybe it just didn't work out. There is some evidence that contradicts that, and people do think that there is some benefit to that. But if you look at like CK as a measure of muscle damage and stuff, I guess my take would be that it's actually much like regular exercise. So we know that there's a repeated bout effect, as in you go to the gym, you do something too hard, your body, you take a beating the first time, but for the next 6 weeks or so, you're pretty well protected from that. So I think we could be using BFR to help with that because it's a stress like anything else, and we can kind of prepare the body to get ready for that. We do see the same kind of CK responses. If we take somebody who's uninitiated to exercise and we do BFR, just like if we put them in the gym and did eccentrics, we can cause some damage for sure. And they should repair to that, but they will get better over time. So whether you're using it before or after, I think basic principles seem to apply.
Bit of a wash. Yeah. Okay, cool. So I guess moving on, unless you guys have anything else you want to add on the IPC or IPC kind of front or performance side? No?
I'm good.
Cool. Then I want to point out you took on this huge task with Stephen, as well as I believe Dr. Warmington was with you guys, of running the Frontiers in Physiology kind of special topics for all things BFR. So kudos to you guys for doing that. And I just pulled it up. You guys had a kind of a review of it. You had 21 articles come out. And what's awesome about it, and also 127 authors overall. It was all done for Frontiers in Physiology. So this is all open access. You can get to those papers, which is what's great. It's a high tier journal. And so that's just a ton of information that we were able to kind of cram into one thing. We also kind of wrapped it up, and we did I can't call it a position stand anymore, whatever we're calling it now, the core Gundam. And we kind of got everyone from different parts of the world to come together and say, okay, now what do we think is kind of best practices here? And then, like all things, there was a spinoff where some of our colleagues over there in Europe came and said, well, you guys got the muscle damage piece wrong. So kind of want to get into that without throwing people under the bus or whatever. We're all friends with everyone that was involved with that. But your thoughts, and people can go and read those editorials. They put their editorial, and then we came back and put an editorial out. In our email streams, I said, from a clinical side, we don't really give a rat's ass. This is not an issue with us at all. We don't care. We're seeing enough from BFR. But what do you think of BFR and muscle damage? And if you want to get into those editorials at all.
Sure. First of all, I'll say credit to Stephen and Stu for organizing. I was lucky enough to kind of tag along and be a part of that. But I think that was a really important contribution, because we really needed to, get all these minds together and say, like, where are we at and what do we need to do better? And I think we've seen real acceleration in the field. And this won't be the final answer by any means. And I think we all know that. And you guys contributed this as well. So it's a good starting point, and it'll be neat to see where we move from that. I'll also say, like, I don't love the controversy that sometimes comes with science. I guess if you're rocking the boat, people aren't going to be upset with you. But I think it is healthy debate to talk about these things. And we're kidding ourselves if we don't think that safety of blood flow restriction and anytime we're doing blood flow manipulation is something we should be thinking about. And I know we've all had those concerns. I'm now at the point where I feel pretty good about most things in terms of, our original thoughts were, are we going to have blood clots when we do this? I mean, are we causing blood stasis and are we putting people at risk? There's now pretty compelling evidence that that's not that big a deal. I'd say the two big things that we're still debating as a field a little bit more now are, what kind of damage are we causing or could we be causing, which I'll circle back to, and also what's the blood pressure response here? The metabol reflex. Are we building up these metabolites and is that being sensed by 3 and 4 afferents and having a total freak out, essentially? Yeah. So let's start with the damage. As I alluded to, I don't think there's any, in my mind, there's no debate that absolutely you can cause a lot of muscle damage. And the groups that raised some issue with that, they've done a really good job in that field, and they're muscle physiologists. That's their world. Right. So full credit where it's due there. I guess where we differ in our interpretation is how much it matters and how surprised we are when we see some of those things happen. So CK is commonly used as a measure of muscle damage. It shouldn't be released into the blood unless something happened to those cells and it was released from them. I guess where we differ is, we do work in things like ultramarathon. So we know that people who go and run for really long periods of time, like they really break down muscles. They cause a lot of inflammation. CK goes through the roof. And so to us, we go like, well, this is not an abnormal response. If you work really hard to something you don't normally do, like people don't run a lot of ultramarathons, even if that's their sport, you just can't. There's an expected change, but typically, knock on wood, people don't die as a result of that. Not that I'm saying death is the only endpoint that matters, but we're not having kidney failure in these kind of things. Yeah. So in a lot of these studies, they did a great job of showing proof of concept that yes, if you take an unaccommodated person and hit them with a sledgehammer, you can cause a lot of muscular damage, for lack of a better term. Now, does that necessarily mean that they had rhabdomyolysis? We would argue no. Right. This might be a normal response, and perhaps you shouldn't be taking people who are not accommodated and ready to take on that kind of an exercise load and hitting them with that, because in this case, a lot of them weren't working out to begin with. So right. I would argue that if you wouldn't be a good personal trainer if you took somebody and just smashed them with eccentrics either. You should probably know better. And I think that's the message that needs to come out of this, is that yes, you could essentially prescribe this incorrectly and hurt somebody as a result, the chances of doing that, if you have proper training, should be quite low.
Right. And I think obviously we all agreed. The hanging your hat on CK is just not a place to go with this. And my background is with the military. If we were checking CK on all these guys, once they got done with their events, every one of them, they'd be freaking out on that there's potential, of there could be some rhabdo event. And there's these hard signs you got to really look for.
Yep.
Are you pissing around?
And I think on the clinical side, this is something that, maybe we have a better appreciation for, just in terms of the things that you see and can measure too often do not tell you the whole picture.
They don't matter.
When I talk about the military story and the background, Johnny, we have the one slide of the guy's limb that's basically been blown off, and then they do the limb salvage procedure and it comes back. And the easy analogy there for us on the clinical side is, well, we have this picture and it tells us a whole lot, and it tells us that this guy looks so much better, but it doesn't tell you anything about the amount of pain that person's in, about their functional limitations. And I think on the clinical side, we see that all the time, where a patient comes into the clinic and we have all of this imaging and workup, and it's like, oh my God, I have this horrible disc bulge in my back. But the person's like, yeah, I'm a 2 out of 10 pain. I kind of just want to get back to doing the stuff that I was doing and not hurting quite as bad as I do when I get active, and so this picture just doesn't quite add up. And I feel like that's really kind of what we're seeing with the CK. So I think, like, on the clinical side, it makes more sense when you kind of construct it that way for people to understand it. And I wonder if on the muscle phys side, maybe I don't want to say a lack of context, but at some level, it maybe kind of seems that way to me from the outside looking in, if you will.
Yeah, I would probably agree with you. Careful how I state that, because I think there's a difference between saying something's a possibility and something is of a magnitude that we really need to be concerned. And maybe I'll use the same example for the arguments we see with the metabolite reflex. No doubt, when we stop venous return and we're building up these metabolites, the metabolite reflex is going to go up. I mean, we have models in cardiovascular physiology like the PICO model, where it's typically done with hand grip, right? You do hand gripping, that's your exercise, and then we cut off blood flow and we let it build up to see how the body responds to that. Like, that's the point. So we know that's a thing, and we can actually measure sympathetic outputs. We can tap right into that, and yep, it goes up. But I look at that and say, okay, yes, I agree with you that if we're using this type of thing, let's say with an older patient, could they have a metabolite reflex? Yes, they probably will. And for full disclosure, to sort of prove this point, we are collecting data on this right now. So we showed that when we compare light load exercise,
I've been on this metabolite reflex thing recently, and I'm like, I just don't know if I'm that worried about it. So I'm great. That's great to hear. Sorry to interrupt, but
that's cool. Yeah. So we showed, like, with light exercise, we get a certain blood pressure response, and we can measure this beat to beat in our lab with some fancy gear. And then we say, okay, what if we do it and then we keep blood flow restriction on during the rest periods as we would? And sure enough, blood pressure is higher, and we're not surprised by that. But it's higher by a magnitude that we kind of go like, yeah, okay. Yeah. And I think when you put that in context of, like, what does blood pressure hit when you actually, so we were doing leg exercise, like hack squats. But if you get under a heavy bar and you squat, and you go back to the work of McDougall in the 80s, I mean, we're talking hundreds of millimeters of mercury.
Yeah.
So if it goes up, like, even if it went up 50 millimeters, which is probably twice the effect that we're seeing, and I kind of go, yeah, but who cares, right? Like,
that's the point. Yeah. No, it's good. We did a systematic analysis of BFR with folks in the heart, the heart trials and hypertensives, and really saw a non-significant rise. I mean, it was just really, again, it's like, okay, who cares? Looks like it's pretty good. So it'll be good to see your work follow up on that.
And I feel like with the vast majority of the studies that have looked at hemodynamic responses to BFR, the magnitude of the increases that you see in the BFR group at no point really reach a threshold for cessation of exercise by any kind of standard that's out there, whether it be APTA, whether it be ACSM, the AMA, ACSM. I don't feel like anybody's really reached that magnitude. So, like, kind of like you were saying, it's like, well, does it matter that much? It's got to matter, but how much does it matter?
Right. I think it's very context dependent. And so, I mean, the proof is in the pudding sometimes. I do think there's still value in understanding what's actually going on, though. So, like, can we reduce that risk 100%. Further? Perhaps we can. I mean, you guys are probably aware there's some work that shows maybe there's a blunting of the metabolic reflex. So we actually get better. Like your body goes, hey, we don't have to freak out about this. This is relatively normal because we do BFR training and we've seen this before. That's something that I think we're interested in. I'm also kind of interested in the idea of like, can we even create super high blood pressures when we remove some of the blood from circulation? When you just think about how a pump works, right? Like what are we generating pressure against if we keep removing more and more blood and keeping it somewhere else?
You're if you do that study, you have to have like fancy names for these studies, Jamie, and that's got to be the vampire study. That has to be the vampire study. Somehow you've got to construct it that
way. We'll call it Twilight or something.
Oh God.
Oh, then my daughters will get excited about it.
Yeah. We got to translate this to the layperson anyway, so maybe that's a good.
Well, I will say, just to give you a bit of insight, I mean, we have the ability to look at with echocardiography, like what's going on with the heart. And sure enough, I mean, we see big changes in end-diastolic volume and what's coming back in the inferior vena cava. So like, it just makes sense, right? You remove flow, it's not coming back. The heart doesn't have the same to push out. So that's going to change things.
Well, and that's so we already have a heart failure trial that's just kicking off down at University of Miami. And that's their hypothesis is removing blood from the heart actually helps the heart's potential to pump maybe. And so you're taking away some of this congestion around it. And so.
That's a really interesting model. I mean, that's like the opposite of what we'd see in like swimming is not recommended for those people because it actually returns the flow. So, hey, let's flip the model. Pretty cool.
Let's take it out. Yeah. Cool. And so future directions for you guys are anything you want to tease? Are you, I thought you were looking at potentially like a diabetes trial. Are you going down that road or?
Yeah, this whole global pandemic thing has wreaked a little bit of havoc on us and for others. We have a lot of, I think, pretty cool ideas. We're pretty excited about some things. Diabetes being one of them. As we mentioned with risk, I think we're in a neat place now where certainly our group, and I'm sure others, we feel a little bit more confident about getting into some of those things that, I mean, from the beginning, I went, diabetes is such a cool area, but these people could have potentially be at a higher risk to begin with, right? Chance of clots or underlying vascular disease. Now, I think we feel pretty good about, at least with pre-diabetics, like let's wade into that a little. Our thinking there is that we can essentially increase the size of the sponge, if you will, right? We know that the majority of blood glucose uptake is at skeletal muscle, insulin stimulated at least. And so if exercise makes insulin sensitivity better, well, what if we kind of use this passive model where we cut off blood flow and then let it go, but we also shock the muscle at the same time through stimulation. So we think we can increase perfusion and possibly take up more blood glucose. So using things like continuous glucose monitors, which are a pretty cool advancement in tech. Nice. We've got some ideas about how we can maybe combine these things to help people who are struggling with that.
I have a study idea that I've been wanting somebody to do. I'm just throwing it out there so you could do it, or anybody that listens could do it
in your spare time, Jamie.
Yeah, in your spare time. You're not doing anything. Right?
Let's be honest, I don't do any work.
Quarantine.
It's all my grad students. So,
and this does not have anything to do with barbecue, by the way. I haven't worked barbecue in at all today, and I just want some credit for that, Johnny. But I really think it would be fascinating to just have subjects come in, do IPC or some kind of a sham, and then literally just have them wear like a monitor that counts their steps and just see, do they self-select to just get up and move around more? Because I think that could be an interesting entry point as well to trying to introduce these people that are generally unaccustomed to exercise, may actually hate exercise, and can we grade their introduction to getting to the point where, okay, now can you just pedal the bike for 5 minutes? And I just want you to get a little tired. You know what I mean? Like, because in the end, when it gets to like, how do I actually manage this person? I got to know where to start. And if just starting in a place gets this person up and moving around more and feeling like a little bit better, that's a win. That's a huge win for us in the clinic. So
100%. And I think, I mean, that's a neat idea about looking at voluntary behavior.
You can stop right there. It's a neat idea. That's all I needed to hear, Jake.
Jesus Christ, Jamie.
I'll take it one step further.
I'm putting that on my Twitter handle, by the way.
Not one of Kyle's ideas has ever gotten anywhere. So yeah.
I'll take it one step further, Kyle. I think what's interesting when we think about like type 2 diabetics, for example, I mean, it's a lifestyle related condition. And many people probably don't realize that one of the real challenges in getting those people exercising, and that, like, going from nothing to something will cause the biggest health effect that we can, because they tend to be fast twitch dominant, not because they're incredible jumpers, but because they don't move regularly. That actually makes initiating exercise really hard, right? When you think about it, it's like everything you did like fatigued you, right? Because those fibers.
I think that's a piece people don't consider at all, to be honest.
That's
with you.
huge.
In the rehab world, like, our heads do not go there, and I think that's. I mean, I think the same applies to like an ACL reconstruction and quad strength and that sort of thing too. So yeah.
Yeah. So I mean, if we can make that exercise even just a little bit more manageable and enjoyable, like, what a great first step. And I mean, we've had the stuff that we do with blood flow restriction and electrical stim. It's been described as like exercise on the couch. And I get why people want to go there. And I don't like to promote that, but maybe there is value to exercise on the couch, right? Like, sit there, watch TV. Yeah. We're going to get you ready so you can actually go do quote unquote real exercise. Like, win-win.
Yeah,
exactly.
Huge. Yeah.
6-minute
abs, baby.
couch to 5K.
Teaming up with Dr. Hope.
Well, awesome, man. Great having you on. You guys are doing badass stuff. It sounds like we're going to definitely need to get you on almost like every month, as much as y'all are starting to churn out now. You're making it hard for everyone else to keep up, dude. So love what you guys are doing up there.
I appreciate the kind words. It's a pleasure to talk to you guys. And, maybe when we get the Twilight study, which was Kyle's great idea, we'll put it out there together.
The first round of Putin is on me. All right. Talk to you later, Jamie.
All right, thanks, guys.
Jamie.
Thanks for listening to the Owens Recovery Science Podcast. Owens Recovery Science is a single source for PTs, OTs, ATCs, DCs, MDs, and other medical professionals seeking certification in personalized blood flow restriction rehabilitation training. Find them online at owensrecoveryscience.com.